In this video, we're gonna talk about application of the Lagrange multiplier to word problem. So the first one is the production function of a product that needs two ingredients given by fxy equal to x squared plus 5xy minus 4y squared. Okay, where xy are the amount of two ingredients. We like to find the graded output, so it's going to be the graded production from the constraint to x plus 3y equal to 74. So if you read the question, you see that this guy will be your gxy equal to 2x plus 3y minus 74 equal to 0. So this one will be your constraint, and you have your fxy given by x squared plus 5xy minus 4y squared. So you're gonna construct the product, the function f x y lambda equal to x squared plus 5xy minus 4y squared, okay, plus lambda, and you have gxy is 2x plus 3y minus 74, okay. So you have fxy lambda given by this function. Let me move this one up a little bit. So you're gonna compute for the first step. Okay, so this one is the first step that you're gonna have f lambda. Okay, f lambda equal to just the constraint 2x plus 3y equal to minus 74 equal to 0. Okay, and you have fx fx will be 2x plus 5y. It's gonna be plus 2 lambda equal to 0, and fy equal to 5x, okay, minus 8y, okay, 5x minus 8y plus 3 lambda equal to 0. Okay, so from here you're gonna solve for lambda. So lambda will be 2x plus 5y over negative 2, and another lambda from fy will be just 5x minus 8y over negative 3, and you have lambda are the same. Okay, so you have lambda equal to lambda like this. So from here, you're gonna be able to have 2x plus 5y over minus 2 equal to 5x minus 8y over minus 3. Okay, so you cross multiply this one. Okay, so first let's get rid of negative side. So you get 3, so it's gonna be 6x plus 15y equal to 10x minus 16y. Okay, so this one will be 4x here, and you get 31y. Okay, so you have x equal to, okay, the number is not quite right, so it's going to be 31y over 4. Okay, so you have x equal to 31y over 4, so you're gonna put into the first equation. So this one will be your first equation. So you're gonna put this number into this guy. So you're gonna have x equal to 31y, and this one will be your x. So you would get 2 times 31y over 4 plus 3y equal to 74. Okay, so you get so you're gonna solve for y in this case. So the way to solve for y is gonna be you're gonna just have 31 over 2y plus 3y equal to 74. Okay, so here you're gonna have 37y equal to 2 times 74. Okay, and you see that you can get rid of 37, so it's going to be 2. So it's going to be y equal to 4. Okay, not bad. So you have y equal to 4, and you can plug in into x. So in here, you're gonna get x equal to 31. Okay, so you have x equal to 31 and y equal to 4 for final answer. Okay, so you have x and y in this case. So the critical point turned out to be 31 and 4, and you're gonna have the maximum profit. Okay, so critical point is 31, 4 is the critical point. Okay, and the maximum profit, maximum production, and the maximum production is F at 31 and 4, and you compute for value. Okay, so this one will be the final answer. So you just plug into the function and you done here. Okay, so that is the first one. Okay, the second one, again about the production function, we have the computer company has money advertising budget of 60,000. Its marketing department estimate that if X dollars spent at each month on advertising in newspaper and Y dollar per month on television advertising, then the monthly sale will be given by S equal to 90 times X to the 1/4, Y to the 3/4. If the profit is 10% of sale less the advertising cost, okay, so the profit will be 10% of sale and you have to subtract. Okay, so here the word less here is mean you need to subtract the advertising cost. We like to determine how to determine X and Y that is going to give you the maximum profit. So in this case, you like to find the maximum monthly profit. Okay. So let me read the question with you again. So you know that the money that you have will be 60,000. Okay, so this is the amount of money that you have. So you're gonna have X plus Y dollar that you can spend. It's gonna be 60,000. So you're gonna use all of the advertising budget that you have, and you're gonna get the maximum sale and you're gonna compute the profit. Okay, so in this case it's gonna be if the profit is 10% of sale less the advertising cost. So in this case the profit gonna be 10% of sale. So the profit will be 10% of sale, so it's gonna be 0.1 is, and you're gonna have to subtract the advertising cost. Okay, so in this case it's gonna be 0.1 times 90 x to the 1/4 y to the 3/4. Okay, and you're gonna subtract by okay, 60,000. So the profit turned out to be 9x to the 1/4 y to the 3/4 minus 60,000. Okay, so this one will be the profit function that you have. Okay, and you have the constraint. Okay, so this one will be the pink function. And you have the constraint given by the yellow function. So you're gonna construct the capital F x y lambda. Okay, so f x y lambda will be your profit. So you like to find the maximum of the profit function minus 60,000. Okay, subtract plus lambda, and you have the constraint x plus y minus 60,000. Okay, so this one will be the f x y lambda that you have. So you're gonna compute f lambda. So f lambda would be just the constraint. So it's gonna be x plus y minus 60,000. Fx, fx is gonna be, you gonna differentiate this one, so it's gonna give you 9, okay, and you have 1/4 x to the negative 3/4 y to the 3/4, okay, plus lambda, and you have fy equal to 9, and you have x to the 1/4, okay, and you have y 3/4, x to the, not x, y to the 3/4, sorry, y to the negative 1/4 plus lambda, and you have all of them equal to 0, okay, so you would get lambda equal to, okay, so for this one, so it's going to be negative 9/4, okay, and you have y over x to the 3/4, and you have lambda equal to negative 27/4 x over y to the 1/4, okay, and you're gonna have these two guys are the same, okay. This allows you to have the relationship between x and y, so you can get rid of negative like this one, and you're gonna cross multiply this one up, so you would get y equal to 3x. Okay, so you have these two guys are equal to, so you get this guy and this guy, you get 3x on the other side, and you have y on the right side. So you have y equal to 3x, and y equal to 3x will be used here, okay? So you would get x plus 3x equal to 60,000, okay? And so you get 4x equal to 60,000. And this allows you to conclude that, so you're gonna have x equal to 15,000, and you're gonna have y equal to 3 times 15,000, so it's gonna be 45,000. Okay, so you just spend 15,000 on newspaper, and you're gonna spend 45,000 on TV advertising. Okay, so this one will be give you the maximum sale, and that's gonna give you the maximum profit in this case. Okay, so this one, you have x equal to 55,000 and y equal to 45,000 for the production function here. Okay, the next one, okay, the next one, when you read the question, you're gonna see that the Mr. Lee and Mr. Kim shopping for shirt from two brand. Okay, the first one costs 500 baht each, while the second brand shirt only 300 baht each. If the certification function for Mr. Lee and Mr. Kim, okay, so you have xy equal to k1 and xy square equal to k2. So for this one, you're gonna have the certification function for Lee and for Kim. Okay, so you have for x and y respectively. If okay, if Mr. Lee has 60, not 60, 600, not 600, 6,000 baht, how many shirts of each brand should he buy allow maximum certification? So you see in this case that you're gonna have the function, okay? So you're gonna have f, x, y, lambda, okay? So you're gonna have the constraint, okay? So I'm gonna have to construct the constraint, sorry. So the constraint in the first case will be you have 500x plus 300y equal to 6,000. Okay, so that's your first constraint. And the second one, Mr. Kim has 4,500. So the constraint for Mr. Kim will be 500x plus 300y equal to 4,500. Okay, so you like to find the maximum certification for Mr. Lee and Mr. Kim. So for number one, you're gonna construct f, x, y, lambda, and you're gonna use the certification function for Mr. Lee. So it's gonna be x, y, okay? And the constraint will be 500x plus 300y minus 6,000. So in this case, it's gonna be 5 lambda 500x plus 300y minus 6,000. So this one will be this constraint, okay? And you're gonna use Lagrange. So it's gonna be, you're gonna have f lambda, f x, and f y. Okay, and you're gonna find the critical point and you're gonna have the maximum certification. For the second case, for Mr. Kim, okay, so I finished Mr. Lee, like so. So the second case, I'm gonna do Mr. Kim. So in this case, you're gonna have to construct the function g, x, y, lambda. So you have xy square, okay? So that will be the certification for Mr. Kim. Okay, so this one is Kim, this one is Lee. So you have xy square plus lambda, and you have 500x plus 300y minus 4,500. Okay, so this one will be the constraint for Mr. Kim. Okay, so this one will be the constraint for Mr. Kim. And again, you're gonna do fx if not fx, f lambda, if x and if y. Okay, so you have three guys like this, and you gonna, okay, so you gonna have this one. Okay, so you're gonna have this one, and then you're gonna have f lambda equal to 0, fx equal to fy equal to 0. So you're gonna have the maximum satisfaction for Mr. Kim and Mr. Lee. Okay, the third question asks you to compare who would get more certification. Okay, so that will be the third problem. Okay, who would get more certification? So this one will be the answer. So you have to compare number 1 and number 2 in order to answer the who would get more certification. So I will let you do this 1, 2, and 3 on your own first, and I will give you the solution when we have the recitation. Okay, so this is the idea. I have G, sorry. So this one will be G lambda, Gx, and Gy. Okay, so that will be the word problem here. Okay, and I'll let you do this one by yourself first, and then I will give you the solution when we have the recitation. I'm gonna conclude this clip by talking about what can we do when we have multiple constraints. Okay, so when we have multiple constraints, so we have the function that we would like to find the maximum or the minimum. So this will be your pink function. Okay, and we like to find the critical point subject to the constraint. So you have two constraints in this case. It's going to be the yellow and the green constraint. Okay, so we would just want to construct an auxiliary function. So you're going to construct the same thing. So you're going to have f. Okay, so in this one, you're gonna have your gxy equal to x squared plus y squared minus 8 equal to 0. And you have hxy equal to yz minus 8 equal to 0. Okay, so we're gonna be able to use the method of Lagrange multiplier again. However, the variable turned out to be more. So in this case, it's gonna be x, y, z. Okay, and you're gonna have lambda 1 and lambda 2. A little bit complicated. Okay, so it's gonna be 5 variable. And you're gonna just use the same idea. So you have xy plus yz, okay? And you're gonna plus lambda 1 times the first constraint, which is x squared plus y squared minus 8, okay? And you're gonna have lambda 2 multiply yz minus 8. Okay, so this one will be the green constraint and the yellow constraint respectively. Okay, so you see that it's going to be just apply the same idea to the yellow constraint and the green constraint. And for the yellow one, you use lambda 1. For the green one, you use lambda 2. Okay, so if you have more than 2, you have plus lambda 3 and so on. And the idea for the critical point turned out to be you're gonna compute f lambda 1, f lambda 2, okay? And you're gonna have f lambda 1 to be just the yellow one, x squared plus y squared minus 8. And you have lambda 2 to be yz minus 8 equal to 0. Okay, and you're gonna differentiate with respect to x, with respect to y, and with respect to z. So you find derivative with respect to x is going to be y, okay, and derivative with respect to y, okay, sorry, derivative with respect to x is going to be y plus 2 lambda 1x, okay. Derivative with respect to y a little bit complicated because you have many y, so it's going to be x plus z, okay, and you have derivative with respect to y, so it's going to be 2y lambda 1, so it's going to be 2 lambda 1 y, and derivative with respect to y, so it's going to be plus lambda 2z, lambda 2z, okay, and you have fz is gonna be y, okay, and you're gonna have y lambda 2, okay, so it's gonna be y lambda 2 in this case, and you're gonna have all of them equal to 0, okay, so you have all of them equal to 0, and you're gonna note that, okay, so since you have the constraint yz equal to 8, okay, so since yz equal to 8, so you get y not equal to 0. So y not equal to 0 will allow you to solve for lambda. So lambda 2 must be 1. Okay, so lambda 2 must be 1 from the last equation. Okay, so you have lambda 2 equal to 1. Okay, so this one will be your lambda 2. Okay, so lambda 2 equal to 1. And you have lambda 2 equal to 1. Sorry, lambda 2 equal to negative 1. Okay, so lambda 2 equal to negative 1. So you have lambda 2 equal to negative 1. So when you plug in lambda 2 equal to negative 1, this will allow you to get rid of this guy, okay? So you're gonna also have equation here, okay? So you're gonna have lambda 1 equal to negative y over what? Lambda 1 equal to y negative y over 2x, okay, negative y over 2x, and you're gonna have lambda 1 equal to, okay, so you see that lambda 1 from this equation will be negative x over 2y, negative x over 2y, okay, and you see this one will be both lambda 1, okay, so you see that this guy turned out to give you y over 2x equal to x over 2y, okay, this allow you to have y squared equal to x squared, okay, so you have y squared equal to x squared, and this is great because you're gonna plug this one into this equation, okay, so you see that it's gonna be a little bit messy. Let me use other color. Okay, so you have y equal to x squared. So you have x squared plus x squared equal to 8. So you get x squared equal to 4. This would lead you to x equal to plus minus 2. Okay, so you have x equal to plus or minus 2. So you're gonna have y equal to, okay, so x equal to 2. So you get y squared equal to 4. So you would get y equal to plus minus 2. and x equal to minus 2, so you get y square equal to 4, so you get y square, so you get y equal to plus minus 2 also, okay? And after you have y, you're gonna use the last equation. So you have y equal to plus minus 2, so y equal to 2, so you would get z equal to 4, and y equal to minus 2, you get z equal to minus 4. Okay, so you get y and z respectively, like this one. Okay, so our critical point, okay, so our critical point are, so you're gonna have the critical point, so you're gonna have to collect x, so you have x, y, z, okay, so x, y, z, and it's gonna be, so you have to collect x equal to 2, y equal to plus minus 2, okay, so you have x equal to 2, y equal to 2, okay, y equal to 2, z equal to 4, x equal to 2, y equal to negative 2, z equal to negative 4, okay, and x equal to negative 2, y equal to 2, x equal to 4, and finally you get negative 2, negative 2, and negative 4. Okay, so it's gonna be 4 critical point in this case. Okay, so you have 4 critical point, and if you like to know which one gonna give you maximum, minimum, you're gonna have to compute the value at each critical point. So you're gonna compute the f at, I would believe that f at 2 to 4 will give you the highest one, right? So it's gonna be 2 times 2, which is 4. So it's gonna be 4 plus 8 equal to 12. Okay, I think this one should give you the highest one. Let's compare other, 2 negative 2 negative 4. Okay, so 2 negative 2, so it's going to be negative 2 plus 8, so it's going to be 4. And you have f at negative 2 to 4, so it's gonna be negative 4, it's gonna be 4 again. And finally, f negative 2, negative 2, negative 4. So for this one, it's gonna be 4, and it's gonna be 8, so it's gonna be 12. Okay, so you see that you have maximum and minimum. Okay, so this one will be max, min, and min, okay, from each critical number. Okay, so for multiple constraint, in my opinion, the idea for this one turned out to be the same, that you use your pink function. Okay, so you use your pink function here, okay, and you just have multiple multiplier. Okay, so you just have multiple multipliers, so you have lambda 1 and lambda 2, okay, and you can just solve system of equation. The hard part turned out to be on algebra, not on calculus. On calculus, it's going to be just you find the partial derivative with respect to each variable. However, the hardest part turned out to be you have to solve the system simultaneously. Okay, so I gonna stop here, and in the next video clip, I will conclude that the I'm gonna conclude and I'm gonna compare about the second derivative test and the Lagrange multiplier for you, and we're gonna do more example on the application on the word problem. Okay, so that's gonna be all for this clip.